I frequently get asked this question by skeptical teachers. Does NGSS really lead to higher test scores? To answer that question, let's go back to the birth of the NGSS. Before they actually developed the new standards, they went and looked at the countries that had the highest scores on these international science tests and said, what exactly are they doing? One of the things that they found was that standards that were based around, quote, unifying ideas seemed to confer more benefits than a discipline-based structure. So what are those unifying ideas? Well, that's where the birthplace of the cross-cutting concepts comes in, these things that occur over and over again in science. And this makes sense when you think about how we learn. We learn better when ideas are connected. So if you have each separate idea addressed simply one time, you're not going to learn nearly as well as when you reinforce ideas multiple times. In fact, many people define knowledge as the connection of ideas. And if you're not making those connections, you're not building knowledge. In addition to the unifying ideas of the cross-cutting concepts, those researchers also identified the ability to use inquiry, which essentially grew into our science and engineering practices. So really, when you put all three of these dimensions together, this is where NGSS was born, was based upon successful strategies on tests by other countries. So we have our first piece of evidence to answer this question here, is internationally it definitely works. But there's also a huge body of evidence that shows here in the US that inquiry leads to better achievement. And so let's take a look at some of those studies. One of the ways that we show using statistics that an intervention works well is something called an effect size. And so effect sizes range from 0, like something like offering universal breakfast at school, a good idea for many reasons, but doesn't actually have that much of an impact on math scores, all the way up to things that have a huge impact on the results of a test, such as race on the SAT, which has an effect size up here in the range of 1. The power of inquiry-based instruction has been analyzed by authors from the 1980s up through the 2010s and beyond, consistently finding effect sizes in the small to moderate range. So we actually are getting some bang for our buck. Let's zoom in on these types of results a little bit more. Here we're looking at who learns better, students in an average US classroom versus those who have been exposed to project-based learning. Now, it's not quite the same as inquiry-based learning, but it's going to give us some insight into things. We're going to look at results for the NAEP, a large nationwide science assessment. And we'll focus in first on multiple choice questions. Who learns better? Well, students that were exposed to project-based learning score significantly better than average on those type of questions. This effect is even bigger when we look at short answer questions, and then we look at the large constructed responses where students need to write extensive answers and really explain their thinking. Well, the students in the project-based learning group score way better than average US students. And we see this general trend here that the more open-ended questions are, the better prepared students are than when they've had something like inquiry learning or project-based learning. So I suppose that you could answer this question of does NGSS lead to higher test scores with, well, it depends on the test. And it really does. If you're trying to produce standardized tests with just facts and information, like what's the definition of energy, well, inquiry-based instruction is not for you. It's not going to be the best tool. But if you're having an authentic test of scientific inquiry, like why do you think car A is more efficient than car B? Well, you need to teach inquiry to learn inquiry. And if we're trying to prepare our students to be scientists that are ready to do inquiry on their own, they're going to need practice. And this is really confirmed by a lot of other studies of inquiry-based learning, which show that when you use an inquiry-based science pedagogy, it doesn't really have a strong effect on science content assessments. No benefit, but also no detriment. There's no cost. You don't lose out on anything in terms of learning the science content. But what you do get is you get additional skills. You get the strong influence on science inquiry skills. And when you assess those, students that have this inquiry-based science pedagogy score much higher than students that had some more direct instruction on things that might have done just as well in the science content, but they're lacking in the ability to do inquiry on their own. One last thing, we can't push this too far. The PISA, which is a large international test, it actually asks questions about how often students engage in different types of inquiry. And the point is that you can't do all the types of inquiry all the time. So, for example, it's important that students spend time in the laboratory doing practical experiments. But if you do that every lesson, your students wouldn't actually learn science as well. There's a sweet spot here where you're doing that some of the time. Likewise, students asked to draw conclusions from an experiment that they've conducted. Again, you'd be going very slow. You wouldn't get very far if you did that in every lesson. So you need to do that in some lessons. There's that sweet spot. Getting to the point where each of us as teachers is able to find that sweet spot and know the balance of practices and how much support to give our students, that's the challenge that we face in coming times. But in terms of the answer of does NGSS lead to higher test scores, the evidence we've got so far says yes.